morning or good afternoon to all. Today, for the 19th episode of our CATIA TV series, I am very pleased to welcome Thomas Balle.
Thank you.
And Hugo Barbalata.
Thank you.
On board. Thomas heads the CATIA Design Center of Excellence for Europe, Middle East and Africa. And Hugo is an expert in CATIA design. Together, they will present how to go from concept design to product experience and perceived quality. As usual, at the end of their presentation, Thomas and Hugo will answer some of your questions. So thank you to those who already sent us questions. If you want, you can still ask questions during the broadcast by using the chat pane or the comments area. And all questions and answers will be published with the webinar recording in the CATIA user community. This is where you can watch previous webinars, find answers, make comments, or ask new questions, and we will answer you. You can also write to katia.contact@3ds.com if you prefer an email response. I hand over to Thomas and Hugo now and wish you a very inspiring webinar.
Hello, everybody. And first of all, thank you, Anne, for having us today. Me and Hugo will today show you about the creative process from concept design to product experience, design validation, and perceived quality. So here we see an overview of the different domains, and I will start out with the concept design first. So when we look at the traditional process, it's highly segregated. It means you shape your design in a tool that's different from the one that you visualize. And for instance, now with the new technologies like VR, that problem is multiplying. Especially when you look at the centerpiece, which is the conversion of the data. So it means every time you do a design change, you have to start all over. So you shape, you convert, you visualize the data, and then you find out you need to change. And that is, of course, very costly. So on a 3D experience CATIA-based integrated workflow, all of this is not relevant because we shape with the same tool or on the same platform as we do the visualization. So it's more about keeping things, changing them, adjusting them, reshaping them, and then just walk over to the visualization with the same data, no need for conversion, and therefore no issues, and of course a process that is much more quicker than the traditional one. So let's start with the concept design. So the concept stage is, of course, the very beginning of everything we do in the creative process. I want to talk to you a little bit about the products. And here, first of all, I think CATIA Human Design is a very important application. So what's the basis of it? Often you find yourself designing for humans, and so we think that human-centric design is the key part. So what we think is that with a human reference in 3D, you are able to make better design decisions and have, let's say, a control over proportions, behaviors, postures, and that will really speed up your design workflow. So Hugo will tell you a little bit more about this later. Nevertheless, I will point out where we see the benefits mostly. So for instance, when you look at transportation design, then we design around a human being. So the human is the center of our considerations. So for product design, often it is the case that we design on a human. So this is, of course, an important difference, but nevertheless, we think we serve all of these requests with CATIA Human Design. And this is why we included the application in every of our creative solutions. So again, the most important takeaways here is we have mannequins of different gender, sizes, and we are able to have different postures. We have a rich library of already predefined postures and mannequins, and we have some specific features that we think will be a big benefit for the users. So in this case, I want to show you a little aspect of human design. So you see we are checking the interior of a car. And now here we see the auto grip function. So watch closely the hands of the person. So it grabs automatically the steering wheel, and we just move the hands towards the steering wheel and it will automatically attach. Now, an added value is that we can attach the hands to the object. So you see we have sort of an inverse kinematic. So once we move the product, the mannequin will adjust its arm. We can have it the other way around. So in fact, the hand is moving the object. So you see there's a lot of different applications for this, especially in the interior design, but of course for product design too. So let's go to the next stage of concept design. We have an application called CATIA Natural Sketch, which allows you to express and communicate your creativity in 3D. So actually, we want to move you over from a 2D approach, like saying paper and sketches, going straight into 3D space and 3D reality. So here in this case, I would just want to illustrate a concept. So you see this car is being done in Natural Sketch. We see the process a little bit later, more in depth. But my intention here is to show you that just with that little bit of wireframe, curves in space that you created thanks to using a tablet, you already have a great impression of a product. So you don't need to have a surface model or a detailed model to get your ideas across and, let's say, some emotional aspects that you think is important on the design. For instance, here, we think that the headlight is not expressive enough. And thanks to the Natural Sketch, we are able to just create a 3D curve in space. Of course, what you've seen below is that there is a surface that we can sketch onto to make things easier, but it's not necessary to do so. As you can see, a design change is done very quickly and will usually work out quite well. In this case, for instance, we look at shoe design. So the expression here of the artist is to do an ornament on a shoe, and it works out quite quickly using a tablet and directly drawing onto the shape of the shoe. And thanks to the 3D experience, you get a quite nice look and feel already in the early stages. So another point that's worth mentioning is that we are not trying to mimic a pixel-based approach. As you see, we're doing curves in space. And with that technology, we are able to create directly from 3D curves, surfaces and everything that will define the volume of the object. In this case, we do simply a connection between the curves that we just created in Natural Sketch, and we create surfaces straight here. Nevertheless, sometimes it's not necessary just to create something. Maybe you just want to communicate some changes on your object. So Natural Sketch has a provision for that too. So it's enabling every user to directly sketch on the object or make comments and remarks so that you can communicate with other departments or other people who are not on the same creative process as you are to explain what you would expect, what you would like to see. And the best part of it is those people can reflect their ideas back to you also in a 3D sketch. We can even integrate some artwork to make clear what we need to see here on the model side, for instance. And all over this, you see the communication is improved with Natural Sketch. So the next level would be, of course, to expand this Natural Sketch idea into VR. And this is what we are seeing here. So instead of going for a traditional approach, as you can see here with the tablet, and this is basically a digital pen that you use in order to draw your curves. So we started, let's say, with a little bit of a design first on the tablet. We try to explore some shapes. And as you can see, we're not creating pixels, we're creating curves in space. So once we have reached a certain stage, my colleague will simply switch over to the HMD device, activate the VR application, and start to sketch something directly in VR space. So as you can see, the experience is of course different because you can really understand proportions, shapes, sizes much better with a HMD device than you can of course do on paper or even if you use the traditional Natural Sketch. So as you can see, we can intuitively create some lines in here. We have some auto snapping that allows us to connect the curves. And you see, we can move them, we can transform them, and scale, for instance. I think the best part of the application is really to create something on the fly, very creatively, just go with the flow. And even the movement in space and being immersed is a value that you should not underestimate. In this case, you see we're just trying to refine the model. And we're trying to do this wing mirror, for instance. And you see with just a little bit of a stroke here and there, you can already see this object coming to life. And of course, you can sort of display this to another person, also with an HMD. And so I think it's the best way to get your creative ideas across. Because often there's an issue that you exaggerate on the 2D sketch, while here in 3D space, this is all working out direct in front of your eyes. And you can see we can even create surfaces, and those surfaces stick onto the curves. And finally, if we go for the next step, we can reuse what we've just did in Natural Sketch VR and use the next application that I'm going to show you, which is Imagine Shape, to improve the model. So what is Imagine Shape? First of all, it's a very easy to use, quick concept modeling tool that is based on subdivision surfaces. And I think the most benefit you get here is that the surfaces you create from Imagine Shape are usable in any other CATIA modeling app. It's fast and easy to learn, which is of course a benefit too. So I show you a very, very quick process here. So it's a time lapse of what I did. So we get, and this is a benefit I think of the 3D experience platform, we get as an input, for instance, a platform of an electric vehicle, and you start to model something, a concept, straight on in subdivision surfaces. The benefit, of course, is that the surfaces you get are reusable in other processes. So you can pass it to the engineering, for instance, or let's say a quality benefit here is that the surfaces themselves are curvature continuous, so you don't have to worry about that aspect. And you see me here doing very quick modifications that usually would take a lot of time if you would create it based on standard surfacing tools. So this is really about shaping and experiencing in a quick fashion. And you can see, thanks to the good visualization we have in 3D Experience with the real-time visualization and the live rendering, which we show here, we can have a quick display of our model and check the quality. And for instance, here we see live rendering, which is based on a GPU rendering process. And you see the model is rendered in real time, and you can see all the reflections and check if the quality on the first glance is okay. Nevertheless, we have something different here. So often in, for instance, industrial design, you have the issue of how to create patterns and put them on a 3D object. So with a little tool inside Imagine Shape, we are actually able to deform a subdivision surface based on a picture input. And this way, you really create a surface that is manufacturable in a sense. It's not a trick, it's not a texture, it's not a bump map. It's in fact deforming the surface, and such it can be used for, let's say, 3D printing straight, especially on those tiny little details. And let's say there's another use for this. When we want to do a rim design, for instance, of course we could start with the usual approach of creating a revolved surface and doing a pattern and so on. But there is a much easier process. It's the same functionality all over again. So you create a basic subdivision surface and now simply place the image of the design you made in some other application, pixel-based, directly onto this surface. You position the image, and you can already see that we can deform the surface really in 3D. Now, when we modify the surface, of course, the modification will be updated. So you see, we're trying to go from a flat surface, so a flat rim, to something concave, convex, what you like to do. And now the power of the 3D experience and the CATIA platform is simply that you can use conventional surfacing tools to, for instance, split the surface. And you see this is a live process. We've taken something that usually takes hours to something that is done in minutes. So another aspect of Imagine Shape is the possibility to work directly on polygon data. Polygon data is usually in our processes scan data. In this case, the back of a car has been changed in the physical model. And now with the use of the optical scanner, we can pull it back into CATIA. Now you see with Imagine Shape, we are quickly able to recreate the area that we need to change. And you see we can add the surface polygons here and directly onto the scan with minimal deviation. And in no time, we're able to recreate again an area that usually, if you take normal, standard, traditional process tools, would take at least an hour to do so. Especially the quality aspect needs to be highlighted because, again, these surfaces you create are curvature continuous, and that's a big benefit because you can see the highlights are working out quite well, or let's say the reflections, and you're pretty much done at this point and can pass the data back to the engineering. So to something completely different in a sense, but which is part of the concept design too. It's about our new tool, which is called CATIA xGenerative Design. So the idea behind this tool is how can you create something like a pattern, like a very complex pattern in an automated fashion. So this tool is actually algorithm-based and creates patterns based on procedures and has a node-based visual interface that allows you to quickly create such difficult shapes just based on connecting nodes in a graph. One thing that we need to highlight is that this is a first kind of a browser-based solution that we are offering. So in this example, we try to do something for a front grille of a car. So first, we start out with a more or less standard knowledge-aware approach, which is defining parameters and then adding those parameters to create some curves. So once we cross this stage, we open up the graph in xGenerative design. And now you see the approach is a little bit different. We have a visual interface, and we have different operations that are nodes in our context. And you just connect these nodes to automatically produce a mass of objects of the same type and of the same fashion. So in this case, you see the process is we adding nodes, we adding operations to end up with a very, very complex shape for a grille. And you can see that we can create procedurally surfaces, points, curves, and in the end, you got a complex mesh that you can just easily modify by using some basic parameters. So I just want to give you some impressions of what could be possible, in this case for a cabin interior. So you can explore a lot of shapes and different patterns just in no time. A project we did lately using xGenerative design is the so-called DB concept car. It was created by Mr. Yamamoto, and the idea was to create a car for David Bowie, and it should express the different personalities and characters that David Bowie played over his career. And as you can see, the car is very unconventional, and the challenge was how can we create something very complicated in here. So as you can see, the creative process was quite interesting because we had to involve so many different designs, features, and ideas. And I think it would be impossible to do something with a traditional parametric approach or even do it manually. So one of the things that you can see here is that we even can use audio files as an input for the creation of the geometry. And in this case, for instance, we try to have this as an input for the creation of the mesh on the side of the car. And here, simply, the process is we create the boundaries of all these tiny pieces and then connect these elements to the center boundaries and get a nice, interesting, organic-looking pattern. So it's just one example of the many different examples that could be produced with xGenerative design. So coming over to Class A surfacing. Why Class A surfacing part of the concept design? Of course, in the traditional process, many companies use Class A surfacing tools also in the very early concept stages. So CATIA ICEM is our tool for Class A, but of course it can be used for concept design too, because it's associative, parametrical Class A. And of course, the benefit here we have is it's based on the ICEM Surf solution, which is the #1 Class A surfacing tool in the world. So in this case, I want to show you a little bit of what CATIA ICEM can bring to concept modeling. So for instance, here we see a part of our blue car. And the important thing here, maybe for a CATIA user to understand, is that thanks to CATIA ICEM, you are able to access the whole mathematic properties of a surface. You can modify the segmentation, the amount of control points. You can change the tolerances, which is one of the big issues, let's say, when you start on a concept model. Maybe you don't want to have too high tolerances regarding surface connectivity or surface connections. And so you can try to use this tool as a means to have some early concepts with already a high quality. And you can change, for instance, between the Bezier representation that we prefer, for instance, in ICEM Surf, and the classical NURBS or NURBS representation of surfaces as we do in CATIA. So it's just one of the examples here. So taking it to the next level, I would like to point out where we come from, which is more or less ICEM Surf. Then we moved over to CATIA ICEM. And now with our latest development, we are offering an app called ICEM Design Experience. So it has a new user experience. It has the same direct modeling approach as the two other solutions, but it has a different user interface approach. So we looked at all our application and we find out we need to streamline a little bit the interaction of the user with the software. So thanks to the 3D experience, we have a different approach. So we can have the surface-based approach, the curve-based approach, and on top of it, we have something we call soft parametrics, which is more or less deciding if you want to do your modeling with all the associativity, or let's say more old school without any history. So I want to show you a little bit of an example on the user interface and the changes thereof. So for instance, a big part of the new development is how you, as a user, can interact and indicate to the system what you want to create. Instead of defining, I want to create a blend here, you just select the two surfaces that you want to connect. And basically, the system will understand, based on the number of inputs, what is expected here. And you see, we can directly model the surfaces in order to increase the quality, the highlights. And of course, here, a little bit of an example on how to optimize the quality. Now, going to the next step, we see with only 2 inputs, we create a blend. And you see how quick it works. So you just hover over the 2 edges and you get the connection. Now, the interesting part is when we move over to a 4-sided patch situation, as you can see here on the top. So we just do a stroke, a selection stroke over all of these 4 edges, and we close sort of with a fill type of surface, but of course, of the highest quality. So this is going to be the future, and I'm hoping we're going to see more in the next release. So in that sense, I can hand over to Ugo, because we are talking about product experience now.
Thanks, Thomas. So now you see all the creative process with Natural Sketch, Imagine Shape, and all our class surfaces and xGenerative design too. Now let's go to experience your product. We have an application, it's named Product Perception Experience, and it will allow you to represent all the stage, the variants, and the behavior of your products. So how it's looking like. We have this user interface, and you see in real time you have your product, and you will be able to quickly create and reproduce all the variants of your product. So here, for instance, we are looking with different angle of cameras, and we will be able to switch off materials, of geometries, of switching and compare your design, and of course you will be able to create animation and move your part. Like this, you will represent all the behavior and all the variant of your product. And with this simple user interface, you will just have to click and play all the stage of it. So it's really great when you have designed your product and have this realistic environment and materials. Now you can have a design review or give to your board or your management capabilities to review all your product design. So you see we have very various scenarios we can offer here. Move variants, cameras, be at the user, get the user perception, for example, and quickly shifting between states. So to achieve this, we have different tools embedded inside this application. So here we have the trigger. With the trigger, you will just select the geometries you want to use. You want to expose as a trigger, and you will just decide which variants you will play. So here we will play with the car paint of the car. So selecting the body of the car, the variant we will play. Here with these features we will highlight which geometries you can click onto, and then when you go in play mode, you will be able to select the body of the car and switch your variants of car paint. So you see in 2-3 clicks I made this trigger on. Of course, you can switch off cameras, you can switch off geometries. So here we will select the hood and we will switch the pattern on the hood, made with xGenerative design. So again, in few clicks, with low skills and knowledge, you can create such interaction with your product. Of course, we offer some integrated behavior inside this application, which means you don't have or you don't need to have some scripting or a lot of knowledge to achieve such animation and behavior. So here I will just simply ask my door to open and close. I will define my point of rotation, so geometries I want to rotate. And then when I will go in play mode, by clicking on it, I create a quick animation and an interaction with the product. So very fast to achieve. And of course, if you want to interact more or get a bit more fun with your product, we have the controller behavior embedded inside our application. So with few clicks, I will select the body of my car, every rim, and it will allow me to control the car and to, I would say, drive it with the keyboard inside the scene. So when everything is ready, just click play, and with my keyboard, I will just move my product. And you see, it took me 10 clicks, not more, to achieve this. But of course, now that you have experienced your product, you want to visualize it in a realistic way and physical-based way. So for that, we have an application named Live Rendering offer with most of our roles. And how we go from here with your native data, with no materials and no lighting on top. How to go from this to here? It's simple. We have in Live Rendering, so inside the platform, a physical-based render engine named Stellar. And it will offer you ray tracing, real-time ray tracing, GPU capabilities, and of course, the next denoiser from NVIDIA. And you will be able to import and use calibrated material or procedurals. And with realistic lighting and ambiances, you will be able to have a physical representation of your product. So for this, we offer a lot of possibilities in terms of materials. We offer first substance material, which is procedural, which will allow you to quickly create some nice appearance of materials. Then we have DSP-BR material, which is most common offering in terms of materials and exchanging between different software. And then we have IXF file format support from Xwrite, which will allow you to scan material and have a physical-based representation. So this is how the DSP-BR is looking. It's a layer-based approach, and with a lot of settings, you will be able to reproduce every kind of materials our render engine can offer. So of course you can have a high quality of flakes, of covering, of coatings, and of course of emissive materials. And we support AXF file formats, which will allow you to get physical samples scanned, import the file inside the platform, and have a realistic appearance of your shape with this material applied onto. And of course, as it's physical based and it's a scan material, you will not be able to tweak it, modify it, and alterate its realism.
Which is a benefit actually for companies that seek to unify their material library.
Exactly. This file format can go from design to perceived quality and of course to marketing then with a single file format. Okay, and we have talked about materials. Now let's talk about lighting. You need to get a realistic lighting on top of your material. We name this ambiences. And to achieve this kind of representation, you will need to import HDF files. So it could be captures of your design room, your physical mock-up room, or your showrooms. And all of this integrated inside the platform, you will get a realistic lighting and surrounding around your product. So here, it's how it looks like in live rendering. We are in the real-time model, and when we will turn on the ray tracer, which is global illumination mode, you will get a realistic appearance with correct lighting, shadowing, reflection, and refraction. Of course, we have the denoiser embedded. So you see with few frames, we get a crisp images. Of course, our Stellar render engine is GPU capable, which means you can really accelerate the way you will render your product. And this GPU-based mode is available with the real-time ray tracing. So here, defining it, you can change your visual quality, for example, and define all your settings of ray tracing, and you can save it. Which means if you have defined your correct settings, you can just save it, reuse it, and share it. No mistakes then. And now we will enable ray tracing with materials, and we will have real-time ray tracing, GPU-based, and you will have quick and fast visualization applied onto your product. It will allow you to make really fast decision taking. And on top right, we are just reusing the ray tracing settings we just set before. Yeah, very fast and very crisp images. Of course, on top of that, as Thomas explained you earlier, we don't have to re-import new data, convert again, and go for visualization and VR. All the tools and the render engine is embedded inside the platform, which means anytime you can modify your geometries with a realistic appearance of materials and lighting, just move around, reshape your surface, and start to visualize your design change. And all of this, you see, it's real time. It will not take more 2 minutes to achieve this. And then, of course, you can switch off environment of ambiences just to validate your design in different lighting configuration. But if you don't have knowledge of achieving such realistic appearance in terms of materials, ambiences, and humans also, we offer Visual Experience Content Collection, which is a library of content you will use inside the platform. So we offer 9 categories of high definition materials, which means if you do close-up or ray tracing, you will have crisp appearance of your shape. Inside this content collection, we also offer ambiences. So it's calibrated, measured lighting, and you will get crisp reflection. It's 8K definition ambiences. So for every close-up and ray traced images, the quality will be here. And of course, on top, we offer different size, gender, and type of humans. Now, let's continue to talk about human design. So as you have design onto or around the humans, now let's validate your product with the human. So you design your product, but you need to check how the human will interact with it, how he will use it, how the product behave with him. So here it's an example. Inside human design, you import the human you have from your content collection, for example, and then you will define postures. It's really simple. You have predefined postures. You can tweak it, And you can create such scenario of use of your car. So here, for example, I'm just showing that the human wants to modify temperature inside the cockpit, and he will just turn a bit his air vents, and I will create this suite of postures. Of course, you can do close-up. It's real time. It's not compute-based. And you can just moving slightly between postures, and you see that when I will change the heater temperature and reach my events, I will collide with my geometries, which means with this application, you can move a bit your air conditioning buttons, or you can move of position, move of area, and just to avoid these colliding situations. So it's fast visualization and fast decision taking to remove objects. Of course, what could be better than to be at the first-person view, just to experience what the user will get from your products. So here, I'm just be at the first-person view, and I will just play my postures and just to understand where my human, or I mean where my user, my consumer will just have a look on. And I can see that some element I can see it well, and some other I cannot see it very well, because it's hide behind some geometries. So, as we have validate our design, now let's go for perceived quality. And of course, in terms of perceived quality, we offer a lot of use case on the platform. So you see, it could be from surface validation, it could be cubing, interior, exterior appearance, applied with the realistic materials and variants. So here, for example, we see here that with the Stellar engine and the ray tracer on, we can validate, for example, reflection on the windshield of the car. So which materials, color or glossy appearance will reflect inside my windshield and will disturb my driving experience. Or also you can see all the icons, the shape is looking beside each other. So if you apply a glossy materials with something paint, for example, or if the icon is not well positioned, your consumer will not have a correct experience of your product, which means it's perceived, how he will perceive the quality of your product is not here. Even if he didn't drive your car, just sitting inside, they will just expect more quality. Of course, if here we compare between the real-time model and the ray tracing, in real time we don't have realistic shadowings. But when I turn on ray tracing, I can clearly see that my cooling system behind the front grille of my car will be hid by shadows. And if I see in the gap between the outer lens of my headlamp and the grille, in real time I can see through, but with realistic shadowing thanks to the ray tracing, everything is hid. Here's the same. If you have designed your metal of the trunk, for example, here, we see this technical shape, which is not really hiding with the ray tracing on, which will allow you to early redefine its position, turn on again the ray tracing, and validate if it's more qualitative, it's more well perceived. And of course, as you have all your data and all your materials, your product is fully assembled, fully dressed with material and with the correct lighting. Now you can do some trim and color review with a perceived quality on top. And you can decide if a material will fit to your product, or if you have to change something earlier, without waiting to get a physical mock-up, which you will get 18 months before the production, and it's maybe too late to change the design or to change of supplier and material applying into it. Here again, you can do some surface validation with gap management, visibility through gap, and on right, as you have animated your products, open doors, do all the cubing stuff you have around your product, you can validate every appearance in every stage of your car, every use that the consumer will do with it. So we have done the creative phase, we have do design validation, we have experienced our product. What's better than to experience it with our VR and immersive tools? So you see all over our release, we offer new features integrated to application we offer. And of course, all of this don't need to have conversion of time, decreasing the quality of your products. You just have to turn on the VR solutions we offer. So here you see we have turned on the VR, so HMDs, And we are just exploring our products. So we offer a lot of features like cutting, just to see what is visible between geometries, for example, if you want to explore more your product without hiding stuff. Or you can simply hiding one by one elements just to reach what you want to visualize. On top of this, we offer transparency mode. So just simply triggering and clicking, you will hide or make transparent elements. So it's real time, very interactive with your models. So clicking, hiding. And of course, you can explode your model. Instead of making everything hiding, you will just have to explode and explore again. Of course, we support cave, multi-face. So again, with head tracking, you can visualize your product with no conversion and no optimization of your data. So just turn on the cave mode, and you will be able to have such review. And of course, you can still interact with your product. So we also offer collaboration between multi-seats. So it means that you will send your data to someone else, stream it, I would say, stream your data, and someone else will be able to visualize and be in the same scene as you. So here we have two different seats. We just ping each other with a chat and say, can we have a review now? And so let's start to explore our model. So here we see, we can interact, we can see who else is inside my immersive experience. And you will be able just to show to your counterpart, to another location or another people of your department, what he wants to show, to see, and you can simply trigger to his headset, to his avatar, and fly into his position. Of course, you see that we have, with Natural Sketch, for the creative side, you can also do VR, which means put your headset and just explore again your design, or you can draw, as you saw with Thomas, which means if you are not happy about your design, if you want to reshape, remodel, modify a surface because its appearance, its reflection don't fit to what you want, you can also do it in VR. It's really simple. You just have to toggle VR, and you just have to trigger and click and modify your surface, create new ones or modify existing ones. And of course, with the realism applied on it. So you kept your material and your lighting. And you saw with human design, you can have the first-person view, but what about experiencing what the human or your consumer will get from your product? So in that case, you will just select your human, be at its place, and with the HMD, you will be able to watch and explore what is around. So again, you will reach a new level of what is visible, accessible, what is around you, and what your consumer will get from your design. And so to hand, we also offer the VR mode inside product experience perception. So once you have defined your trigger, your variants of camera, of materials, of position, of geometries, put your headset, and now start to experience your product. As usual, it's real time. So here we have someone who is triggering the scene and another one who is experiencing it. But of course, you can define trigger, and you can trigger your scene with your controllers in real time, and it's HMD. Like this, you will be able to explore the variants and all the behavior of your product. So this is all the offering we have about VR and immersive tools embedded inside the platform, using realistic appearance and also allowing at any time to do sketching or surface modification and to modify your design. And of course, all of this embedded in one tool.
In our 3D experience platform.
Thomas, we have questions. The first one is, can I reuse the Imagine Shape subdivision in any CATIA application?
Yes, in fact, this, I think, is the biggest benefit of having the subdivision modeler within CATIA. So we know that a subdivision is by, let's say, the tool subdivisions, is something that also other vendors do too, but they have the problem, they need to convert the data to use it for the surfacing process, and often the problem is simply that the surfaces are unusable because of their mathematic nature. This part in CATIA is hidden from the user. It's managed by CATIA, so you can do offsets, you can split surfaces. So it's ideal in the sense to go from concept to engineering, and even for the engineers to modify something and play that proposal back to a stylist. And it's really the biggest benefit I see. It's really usable in every CATIA modeling app we have.
Another question we have is, how is it to switch from an application to another inside the platform?
That's very simple. I mean, we have the compass that opens up, let's say, to the sector where all the 3D applications are available. So it's basically 2 clicks to do it. Sometimes it's even much easier. So for instance, you showed live rendering. So when you go from modeling to visualization, in this case, for instance, you just double click on a structure in the specification tree, for instance, the product, which is the assembly of the part, and automatically the app changes to the live rendering mode. So you press a button and you have the visualization. When you go back to the part level, you're back in the subdivision modeling. And so this is 1 or 2 clicks, if you like, sometimes. Okay, so Ugo, I have a question for you. Do I need to be an expert to do realistic visualization?
Of course not. As you see during the whole presentation, we have embedded features and embedded Stellar Render engine, which allow you to do quickly and fast visualization. And thanks to our visual content collection, we offer realistic materials, realistic lighting to apply on your product and to dress your scene and to have fast visualization without having strong knowledge on CGI graphics application or not being a 3D artist. But you can achieve this thanks to our role and application.
Okay. So I see another one. Is it simple to set an immersive preview?
Of course not. As you see, you have defined your realistic environment and product. You have triggered your scene, create variant with product perception experience, and you can just simply go in the HMD mode, put your headset on, and start to review, explore, move around, explode, hide.
Go back to creation, modify, modeling.
Of course, and triggering and explore all the behavior of your product. You don't need to have strong knowledge in coding or create animation. With few clicks and with a really great user interface, you will be able to achieve such experience in immersive situation.
Thank you very much, Thomas and Hugo, for this very complete presentation. And thank you all for attending this webinar, and especially to those who have asked questions. Again, if you didn't have time to ask your question, you can still do it in the CATIA user community. You will see the link in a few seconds. And this is where you can watch previous webinars and find answers. Well, talk to you at the next webinar. Goodbye now.
Bye-bye.
Bye.